How does pi connect circle circumference, area, and sector properties? Imagine holding a round cookie in your hand. Now, think about how long it would take to go all the way around it, or how much space it covers inside. That's where pi comes into play. Pi, which is about 3.14,159, is a special number that helps us understand all these parts of a circle. It's like the secret link between the straight and curved parts of a circle. When you measure around the cookie, that's called the circumference. Pi helps us find that length by multiplying the diameter, which is the distance across the cookie through the center, by pi. So, the formula for the circumference is 2 times pi times the radius, or pi times the diameter. The radius is just half the diameter, so it's a quick way to find the distance around any circle. Now let's talk about the inside of the circle, which is called the area. The area tells us how much space is inside the circle. Pi helps here too. To find the area, we take the radius, multiply it by itself, and then multiply that by pi. The formula is pi times the radius squared. This shows how pi connects the size of the circle's interior to its radius. The bigger the radius, the larger the area, and pi helps scale that relationship correctly. Next, think about slicing a piece of the circle, like cutting a pizza. That slice is called a sector. The size of the sector depends on the angle at the center of the circle, measured in degrees. To find the area of just that slice, we take the angle, divide it by 360 degrees, and multiply by the total area of the circle. Since the total area involves pi and the radius squared, pi helps scale the fraction of the circle's area that the slice represents. So the sector area formula is the angle divided by 360 times pi times the radius squared. In simple terms, pi is the constant that connects all these properties. It turns the straight measurements like diameter and radius into curved measurements like circumference and area. Without pi, we wouldn't be able to accurately describe or calculate the size and shape of circles and their parts. It's the key that unlocks the relationship between the straight lines and the curves of a circle, making all these calculations possible and consistent.